Assalamualaikum and hi, welcome back. Okay, so here this is the last part of chapter 2, 4 of 4, and we are still in the last subtopic, which is 2.3 absolute values. Earlier we have type 1 absolute inequality, so now we are going to go through the type 2. So type 1, where we have only a constant on the right side of our inequalities. So for type 2, okay, type 2 we have the absolute function on the left side, and we have a linear function on the right side. So if we have this type of inequality, we can use only basic definition. Okay, so let us go through example 16 right away. So let me change first. Okay. So they ask us to obtain the solution set. Now, so here, the question really asks for the solution set. So you cannot give your answer in interval notation. Okay. Satisfying the inequality of that one. Okay. So now first I rewrite the inequality again, as usual. So it is modulus of 4x plus 1 greater than or equal to 2x minus 5. So whenever we have only one absolute value on one side, so we can use now go. Okay, by using basic definition, of course, we can use go. So we have here greater than. So greater than is or. Okay, so we separate these two first and put or in between, or union. So the first one will be the positive one, 4x plus 1 greater than or equal to 2x minus 5. And the other one is a negative one, negative 4x plus 1 greater than or equal to 2x minus 5. So we solve first the left one, okay, the left inequality. Gather them all of x together. So we have 2x greater than or equal to minus 6. So x here is greater than or equals to minus 3. Okay, the next one, I multiply both sides by negative first. So of course, the symbol will change. Okay, we have here negative 2x and then positive 5. Rearrange it, we will have 6x less than or equals to 4, x less than or equals to 2 over 3. Okay, then as usual, highlight the last one. Okay, so because we have only linear inequality here, right? In both of our inequalities, we have only linear inequality. So we do not have to use the graphical method or whatsoever. Okay, or line or table of sign. We do not need that. Okay, so what we need next is the number line to combine back the answers. Okay, so number line. You draw the number line and put the numbers together. So minus 3 and then 2 over 3. So the first one we have greater than negative 3, the dense circle greater than negative 3, and the other one is less than 2 over 3, dense circle as well. So all here means we have to highlight all lines. Okay, so highlight everything where the line is. So we can see it is actually from negative infinity up to infinity. But since the question asks the solution set, so the answer should be in this form. So the curly bracket x, where x is all real number. And then we are done. If in interval form, in interval form, we can write it as from negative infinity up till infinity. Okay, so now we are done with example 16. So we go to example 17, still in type 2. So why is it type 2? Because we have the absolute on the left side and then quadratic on the right side, not a constant. Okay, so if it's not a constant, then we can only use basic definition. And then since it's already absolute function on one side, so we can use goal right away. So this is less than, so less than is and. Okay, so we rewrite it first. So x squared minus 2x less than or equals to minus x squared. So I'm going to separate these two and then write and in the middle. So the first one is the positive x squared minus 2x less than negative x squared. And the other one is negative x squared minus 2x less than or equals to minus x squared. Okay, we solve the first inequality. Okay, so we have here 2x squared minus 2x less than or equals to 0. We divide both sides by 2, so we have x squared minus x less than 0. We factorize this one, so x minus 1. This is a quadratic inequality, okay? So because we have quadratic expression on the left side, and then we already factorized this one. We have the critical values, which are x equals to 0 and then x equals to 1. Of course, this is a quadratic, so we need to draw our smiley quadratic. 0 and 1. As usual, highlight the last one, which is less than. So we need to take the one below the line. So below the line is this one here. So the answer for the first inequality is actually between 0 and 1. Remember, we still need to combine these answers, okay? Okay, so the second inequality, so I multiply both sides by negative, so it will be x squared minus 2x. Automatically the sign will change. So here will become x squared. Rearrange, we will have negative 2x greater than 0. Divide again both sides by negative 2. Okay, so I said divide both sides by negative. So negative means that we have to change the sign. So divide both sides by negative, we have x less than or equals to 0. Okay, so this one we don't have to draw or do anything because this is just a linear inequality. So we just need to highlight the answer lah. Okay, then we have the answer already. Okay, so the answer for the first one is from 0 to 2. Oh, sorry. From 0 to 1. Yeah, 0 to 1. Okay, so now we combine these two answers using the number line. So we have 0 and 1. So for the first one here, we draw it from 0 up till 1. Okay, closed. And then the other one is less than 0. So less than 0. This is less than 0. So the question asks for intersection. And so we have to find where does these answers intersect them. So the lines are not intersecting each other, but we only have here. So they are intersecting at x equals to 0 only. Okay, only there. So therefore, the answer should be only 0. So that will be the answer. So that's it for type 2. Okay. Now we are going to go to type 3, where we have modulus on both sides of the inequality. Okay. So if we encounter this type of question, we have to use only the squaring both sides method. If we have both sides of the inequality with modulus, we have to use only squaring both sides method. Okay, don't be scared. It's the same steps as we learned earlier. Okay, don't worry. Okay, so this is the question. Okay, I rewrite it. modulus 4x plus 1 greater than modulus 2x minus 5. If we use squaring both sides, meaning that we use the distance definition. Okay? So we have to use the distance definition for both sides. So the first one will be 4x plus 1 squared and then the modulus. The third. Say the right one. So 2x minus 5 squared and then the third. So in order to cancel off the surds, we have to square both sides of the inequalities. Okay? Then only we can cancel off the surds. We are left only with the 4x plus 1 squared greater than 2x minus 5 squared. We need to expand them and put them together, simplify until we get the one with 0 on the right of our inequality. Okay, so we expand this one. We'll have 16x squared plus 8x plus 1. So the right side will be 4x squared minus 20x plus 25. So simplify this until we get 3x squared plus 7x minus 6 greater than 0. Okay, so here of course we have again the quadratic inequality. Okay, so quadratic inequality, what do? We have to make sure the x squared is positive. So here it is positive, no problem. And then we have to factorize it. So x plus 3 and 3x minus 2 greater than 0. With our critical values are x equals to minus 3 and x equals to 2 over 3. With our critical values here, we sketch our smiley graph. Okay. With first negative 3 and 2 over 3. Where is our highlighted statement? It is this one. Okay. So we need the one greater than 0. So greater than 0 means the one above the line. Okay. So the answer should be negative infinity, from negative infinity up to negative 3. And the other one is from 2 over 3 up till infinity. How to combine these two answers? Just use the union sign. Okay, so this is in interval form. In solution set, x. So one is x less than negative 3. Another one is x greater than 2 over 3. How to combine this? We put or. Okay, so we are done with example 18. So the last one should be the absolute inequalities involving ratio. Okay, ratio. So this is type 4. Methods in solving absolute inequalities for ratio or rational expression. Okay. So the only one we can use is by using basic definition. Of course, actually, we can also use squaring both sides. But to standardize, in order to standardize our method, just use basic definition. Okay. Yes, actually, for this question, where we have a constant on the right side, yes, we can use squaring both sides method. But here in our example, we are going to use basic definition because there are sometimes few types of question you cannot use you cannot use squaring both sides. Okay, so we are going to standardize and use the basic definition. If you understand where and when to use squaring both sides, you can use it. Okay. So now by using basic definition, remember we have to separate them and then we have to combine them back. Okay. So for this one, solving the inequality for this rational absolute inequalities, I first rewrite the inequality again. So 10 minus 2x over 3x plus 1 greater than 1. So goal, G-O-A-L, since this is greater than, so we are going to use or. Okay, or. I put or in the middle, or union. So the positive one, so 10 minus 2x over 3x plus 1 greater than 1. Another one, negative. 10 minus 2x over 3x plus 1 greater than 1. So we solve first the first inequality, okay? So I hope you still remember how to solve the rational expression, rational inequalities. Remember not to do the cross multiply. So what do? We have to bring 1 to the left side. Okay, so we'll be having 10 minus 2x over 3x plus 1 minus 1 and then greater than 0. We have to make sure we have the 0 on the right side. Okay, so after we get them on the left side, we have to similarize the denominator, samakan penyebut. Okay, so 10 minus 2x minus 3x plus 1 over 3x plus 1 greater than 0. So simplify this, we will have negative 5x plus 9 over 3x plus 1. So greater than 0. So from here, we have the critical values, which are x equal to 9 over 5 and also x equals to minus 1 over 3. So from here, remember, if we have rational inequality, we have two methods. It's either you want to use the table of sign or line method. So why not? For this first one, I'll be using the table of sign. And the second one, I'll be using the line. Okay. We can rewind. We can revise back again the method. Okay, both methods. Okay, so for the first one, I'm going to use the table of sign method. Okay, draw the table. Okay, and then put everything together. Okay, so excuse my bad drawing, So I put here from negative infinity up till negative 1 over 3. This one is between negative 1 over 3 up till 9 over 5. And then 9 over 5 up till infinity. Okay, so the values of x you can choose. So I'll choose negative 1 here, 0 in the middle, and the last one is 2. Okay, and then remember using the calculator, you key in the negative 5x plus 9. Okay, and then calculate, you substitute negative 1 and then calculate, you will get the sign. Okay, so I have here my sign positive and then negative here. You will do the same for 3x plus 1 and you will have negative, positive, and positive. So conclusion, you know what to do. So positive, negatives, negative, positive, 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 negative, positive is negative. Okay, so I forgot to highlight my last statement. Okay, this one. So we want the one greater than 0, lebih besar daripada kosong. Okay, greater than 0 meaning that we want the positive one. Positive one. So the answer for the first inequality is actually negative 1 over 3, from negative 1 over 3 up till 9 over 5. So we stop here first. This is not the final answer because we have yet to combine the answers later. Okay, so we go to the second one. The negative part. Oh, sorry. No, negative 1. Okay, so I multiply both sides by negative. So I have 10 minus 2x over 3x plus 1. Change the sign to less than minus 1. Okay, and then gather everything on the left side so that we have 0 on the right side. So 10 minus 2x over 3x plus 1 less than 0. Similarize the denominator, samakan penyebut. So 10 minus 2x plus 3x plus 1 over 3x plus 1 less than 0. Simplify the left side. We will be having x plus 11 over 3x plus 1 less than 0. We have the critical values, which are x equals to minus 11 and also x equals to minus 1 over 3. So I promised you just now, for the second part, we are going to use sline. Okay, so sline, how to use it. But before that, highlight first. Okay, we want the negative, less than 0, meaning that we want the negative ones. Okay, so sline. Okay, divide into two parts. Okay, so the right part will be our number line. We start off with negative 11 and then negative 1 over 3. So the left side, we are going to rewrite the rational expression on the left side like this. Okay, so choose any number less than 11. So maybe negative 12. Okay, negative 12. And then a number between negative 11 and negative 1 over 3, maybe negative 10. And then the one greater than negative 1 over 3, maybe we take 0. Just choose any value, simple values. Okay, simple values. So I said just now, maybe this one we take negative 12. Here we take negative 10. And here we take 0. Okay, so as I taught you earlier, you just key in this expression in your calculator and then you press calculate button and then substitute negative 12. Okay, you will get the positive sign here and then negative sign in the middle and positive sign in the last part. Okay, so we highlight just now, we want the less sign, less than 0. So it is also in the middle. So the answer for the second inequality is actually from negative 11 up till negative 1 over 3. Remember, this is not the final answer. We have two answers here. We need to combine them. Okay? Remember, we always need to combine both answers. Okay, so now to combine these two answers, we need our number line. We go back to blue. Okay, so we combine these two answers. We actually have a space down here, but never mind. I just use here. Okay. Okay, I'll just draw my number line and put all my numbers that are in here and here. Okay, but put them in order. So we first put negative 11 and then negative 1 over 3 and then lastly 9 over 5. Don't put negative 1 over 3 twice, because this is a number line. So we just have one negative 1 over 3. Okay, so now we put the first answer first, the first answer, which is from negative 1/3 until 9/5, and it's open. So, sorry. So, from negative 1/3 up till 9/5, open. Okay. Another one is from negative 11 up till negative 1/3, and then open. Okay. So, what do we want? Do we want intersect or union? So, earlier, we have highlighted that we want union. So, union is that we highlight, we'll find all the lines, okay? So, it is from here up till there, and then from here up till here. Okay, so how to put this into our answer? So, the answer should be from negative 11 up till negative 1/3, and then the other one is from negative 1/3 up till 9/5. So how to combine these two answers? We put union there. So we are done. Okay. If you want to put this into a solution set, okay, let me show you. Okay, solution set, it will be x between negative 11 and negative 1/3, or x between negative 1/3 up till 9/5. So now we are done with all types of inequality, with all the methods, and we are done with chapter 2. All the best studying for chapter 2, and thank you. Bye.